So this one here, we're going to look at factorizations that may be combinations of the different types of ones that we've seen already. Okay, so this would be kind of the trickiest thing that you're going to see, and what you would need to be able to master to get a 4. Okay, so I'm going to just show you something here really quickly, and this is something we can go over when I come back and when I'm in class again, but just have a look at this, right? So if you look at the first one, we have 3b squared minus 75. So the first thing I need to do is, there's a common factor. The two numbers have a common factor, which is 3. So that could be written as 3 times b squared minus 25. Okay? Now look, if that was x squared minus 25, we'd be talking about it as a quadratic. Just because it has a different letter doesn't mean it's not a quadratic, okay? It is. Now, this is a quadratic because the highest power of the variable is 2. But it's a binomial. But what we can do, we can turn this into a trinomial just by doing this, right? So I'm going to say it's 3 times b squared. But what we're missing is the b number. Normally a trinomial would be like b squared minus 4b minus 25, for example, or b squared plus 3b plus 10, or x squared plus 4x plus something. So it's the letter squared, then the letter to the power of 1, and then a constant number at the end. But we're missing that. So we can write this as b squared plus 0b minus 25. Okay? Now I want to factor what's in the middle. I'm going to factor what's in the parentheses here, and then I'm going to stick the 3 onto the front of it. So if I look at it like that, I've written it, I've pretended that it's a trinomial. So I multiply the number at the front by the number at the end. So I need minus 25 when I multiply. And I need 0, not 10. I need 0 when I add. So the question is, what two numbers multiply to give minus 25 and add to give 0? Plus 5 and minus 5. Yeah? So what we have then is 3 times b squared plus 5b minus 5b minus 25. Okay? So basically, I kind of I pretended that this was a trinomial when it's a binomial. Instead of b squared minus 25, I wrote b squared plus 0b minus 25, just to fill in that gap and allow me to use the trinomial technique. So now, if I factor it, I'm going to get 3 times b, so let me go back and change that for a second, it's a little bit untidy. So 3 times b by b plus 5, and then the b plus 5 goes on the other side, and a minus 5 in the middle. Okay, and that gives us an answer of 3 times b, sorry, 3 times b minus 5 times b plus 5. Okay, now that might be a little bit unclear, okay, but it's the tricky concept, and we're going to go through this in class again. But if you understand it, great. If not, when I come back, you're going to have to ask me questions on it, okay? Let's have a look at the next one. So here, first thing up, always, like I said, we're going to look for any common factors. So if you look at this, look at the number of parts. 5 is common factor to them all. So if you divide that out, you're going to get 5 times a squared minus a minus 10. Now in the parentheses, we have a quadratic. So a quadratic trinomial. So to factor that, we do minus 10, because 1 at the front here, times minus 10 is minus 10. So I need minus 10 when I multiply, and I need minus 1 when I add, because I have minus 1a. So what two numbers multiply to give minus 10 and add to give 1? Is it possible? So the factors of 10 are 1 and 10. That doesn't work. 2 and 5. That doesn't work. So it doesn't work. We've no factors. Impossible. Okay, so our answer is just to leave it as 5 times a squared minus a minus 10. We thought because it was a trinomial it would be factorable, but we couldn't come up with numbers that would work. Right, let's look at this one. What's the first thing I notice? That this has 4 terms. So if it's 4 terms, we split it in 2, and we look at the first two, x is in common. We look at the second 2, 2 is in common. So what do? X times y plus 2, because if we take the x's out, we're left with y plus 2. Then the y plus 2 automatically goes to the other side. Now, what do I multiply y plus 2 by to get 2y plus 4? 2. So my factors are x plus 2 and y plus 2. Alright? Okay, here's the last one that we're going to look at. Now this is hard. This is difficult, right? And I'm going to tell you why. Because we have something squared here, we're going to think of this as being a quadratic. Okay? So our variable, instead of being x, is a plus b. So what we really have here is a plus b squared, and we've 1a plus b squared. Then we're going to think that we've 0 a plus b's, and then we're going to think that we've minus 9. So imagine then, for example, that we just decided we weren't going to use a plus b, we're just going to say x instead of a plus b. Okay, so what you would have is x squared plus x minus 9, or plus 0x minus 9, right? So what you would do is you would say that I need 1 times minus 9, I need to get minus 9 when I multiply, I need to get 0 when I add. So what two numbers? It's plus 3 minus 3, right? So here's what I have. This is difficult, remember. So I have a plus b squared plus 3a plus b minus 3a plus b minus 9. Okay? Now, it's 4 parts, so I split it in 2s. So if I look at the first one, there's a plus b in common, so it's a plus b times a plus b plus 3. Okay? And then automatically the a plus b plus 3 becomes a factor on the other side. What do I have to multiply it by to get what's there? Minus 3. So when I simplify it, I'm going to get a plus b minus 3 times a plus b plus 3. That's difficult. Okay, it's difficult. Imagine if you pretended that these were x's, like I said. Would it be easier? Why don't, instead of writing a plus b, why don't you write x and solve it with x and then see what happens? Okay, the principle is the same.